So let's have the last team SAGA.
Okay, good afternoon everyone. Sorry that we're the last group, we're going to try our best to make it quick. So actually, Team SAGA, and today's presentation will be about a strategic plan to reduce the cancellation rates for
hold on first. So for those of you who can stay to the nothing on, please let them have their 25 minutes as well. Please support each other if you can stay. Right? Let them have their 25 minutes as well, so every evaluation will be fair. Right.
I always you can leave, you want to leave first, I don't know. A bit distracting, sorry. I'm going to start from the top. So, hi everyone, we are Team SAGA. So basically our presentation today will be about a strategic plan to reduce the cancellation rates for Hotel Group 88. And with me I have Keynes and Dave. So we're going to first off start the presentation by addressing the business problem. Okay, so Hotel Group 88 is actually a relatively smaller hotel in Singapore, and it just opened its doors in 2015. So we actually sat down with the CEO and actually found out that there are actually several problems that they face. So firstly, they have difficulties competing in the hotel industry, which is understandably highly competitive. And as a result of that, they actually experience very high cancellation rate of 37%. So to contextualize this, essentially more than 1/3 of bookings are being cancelled. And this is not a really good sign for them. And so what they want is actually a model to be able to minimize the inaccurate cancellation predictions. So what the CEO requested of three of us was to provide a model to them to help them predict whether a new booking will be cancelled. And at the same time, he also wanted the key driving forces that would signify that a cancellation was going to happen, as well as some possible reasons why. And for the last deliverable will be recommendations for preemptive measures. For example, for the instance where the booking is being cancelled, so they want to salvage the situation as much as possible. And we're going to introduce our data set. So on the left, you can see a few rows, a few columns of the data set, but this is not the entire data set. It's just some of the columns. We actually have about 32 variables with a mixture of numerical as well as categorical. And some of the variables that we removed were agent, company, reservation status, and reservation status date. And after removing those variables, we actually have about 500 nulls, which constitute about 0.4% of total rows. So we didn't really do much imputing of the data because it's about only 0.4%. So we just took it as it shouldn't really affect the data as much. Because on the final data side, you can see that there's 28 columns with 17 numerical and 7 categorical with about 120,000 rows, which we feel that is sufficient for us to build the model. And next, we're going to move on to preliminary analysis or exploratory data analysis. So first we started by plotting the correlation heat map of the numerical variables. And we can see that at first glance, the variables are not highly correlated with one another. And this is a good sign for us because it helps to ensure that our model is stable and it will exhibit relatively strong performance. However, you can see from the box, the black box there, we can see that the highest correlated variable is actually between stays in weeknights as well as stays in weekend nights with a value of 0.49. And then afterwards, we wanted to find out why was this the case. So we actually consulted two of our friends, ChatGPT as well as Gemini. So we started by comparing a few of the responses given. So you can see that actually they give relatively similar responses. So on ChatGPT side, you can see that they actually gave promotional offers, or Gemini actually said package deals. While it's not really apple to apple like similarity, but you can see that generally the idea is that it's some sort of like package promotional offers. And you can also see this for the booking preference as well as the length of stay preferences. Again, it's not really entirely similar, but the general sense or idea is there. So you can see that for these two cases, there's not really much discrepancy between the LLMs, as well as it kind of agrees with our own thinking of why those two variables are actually highly correlated. And afterwards, you move on to association analysis between the categorical variables. So this was highly assisted by ChatGPT. So apparently there's this method called the Cramer's V, which we can use to quantify the association between categorical variables. It ranges from 0 to 1, similarly to your correlation coefficient, with 0 being no association and 1 being perfect association. And they also set an arbitrary threshold of 0.3 by the LLMs, which we then verified that it is an appropriate figure to set as high association within categorical variables. And you can see on the table on the left, you can see the highest value is actually between reserved room type as well as assigned room type. And this is, I think, again, we can explain using our own intuition, because usually customers who are assigned the room that they reserve, unless for like any unforeseen circumstances. And then we're going to further explore the data. We we plotted the customer booking patterns over the years, and we can see that in general the hotel has drawn in more customers over the years, and naturally this has led to a higher number of cancelled bookings. But fortunately, we can see that from the graph, the number of successful bookings is always higher than the cancelled booking, which is a good sign. Although the cancellation rates has decreased over the last few years, it's still a cause of concern due to the 37% that we mentioned earlier. And then we went on to see the month-on-month change on the cancellation rates, and we can see that, as mentioned earlier, the month-on-month changes actually decreased over the years. And focusing on the box for the last few months, we can see that it remained relatively constant for the last few years. And this is actually a good thing for us, because this signifies or signals lower volatility, which allows us to carry out more accurate resource planning. And then we went on to see the cancellation rate among the hotel types. And you can see that on the pie chart on the left side, actually city hotel contributes more. Okay, so in case you cannot see, so basically orange is the cancel and blue is successful. So you can see for city hotels is the pie chart on the right. So you can see that it contributes to the higher amount of cancellation rates. And also we consulted ChatGPT on why this is the case. So basically what they provided us was the purpose of the travel for this hotel. So basically, resort hotels actually primarily attract leisure travelers, and these guests actually tend to plan their trips well in advance. So this can result to lower cancellation rates as compared to business travelers. And another reason that they cited was basically low booking lead time. Because city hotels attract visitors with spontaneous plans who finalize them closer to the date, this will contribute to lower shorter lead time. And this is why they said that shorter lead times would be an indicator to the likelihood of cancellations. And here we're going to explore a bit about how when the queries are differing for two queries, we actually get completely opposite answers given by ChatGPT. So on the left, you can see that we queried about the high drivers of cancellation rates in city hotels. And on the right, we gave it a general prompt for the high cancellation rates, the drivers of high cancellation rates. And on the left, you can see that it's actually, they were saying it's low booking lead time, and on the right, it's high booking lead time. And this is in contrast with what we believe, because even though the slide context wasn't given, the answers given by ChatGPT was completely opposite, and we were quite shocked when we see this, because we believe that even though the prompt was slightly changed, the general sensing will be there, and not like completely different answers. And so, in order to do this, we will actually resolve this conflict using domain knowledge as well as further research. And then we went on to fact check LLM's results. So basically, these three companies are actually specialized customer relationship management solutions for in the hotel industry. So we can see from DH, basically longer lead times will have a higher likelihood of getting cancelled. And this is similarly shown from Hotel Minder as well as hotel management. So in this, we can make the conclusion that higher lead times will actually have a positive influence on cancellation rates, and it is appearing to be a key driver in influence cancellation rates. And at the same time, it's also essential that we actually fact check LLM's results instead of just taking their results as whole.
So moving on, we'll be exploring some hypotheses as to what factors will influence cancellation rates. So to do this, we actually combine LLMs as well as domain knowledge to try to shortlist three potential hypotheses and three potential promising factors that will drive cancellation rates. So this will provide us with a starting point and will guide us through our project. And so for the first hypothesis about lead time, which was what Melvin mentioned earlier. So this hypothesis was generated using ChatGPT, and it states that the length of time between the customer's bookings as well as the arrival date will significantly impact cancellation rates. And so the intuition is that customers who book well in advance, there's more likelihood for them to cancel their plans because it changed, or maybe because there's some unforeseen circumstances. And on the other hand, last minute bookings, they are less likely to be cancelled because there are less options, alternative accommodations for customers to fall back on. And so for the next hypothesis, it's about deposit type, and it states that the type of deposits made by customers will affect cancellation rates differently. So specifically for bookings made with no deposits or maybe refundable deposits, customers are more free to cancel them, so it can generally lead to higher cancellation rates. And on the other hand, customers who have already made non-refundable deposits, they are financially incentivized to stay with the reservation and not cancel them. So these two hypotheses generated using LLMs seems to be very intuitive and logical, which is why we chose to shortlist them and keep them as it is. And finally, the third hypothesis was crafted using our own secondary research as well as our clients' domain knowledge, and it revolves around seasonal trends. So it states that the different seasonal traveling periods can affect cancellation rates very differently. So some examples include maybe during peak traveling periods, it draws in more customers, but at the same time it attracts fiercer competition from our competitors, for the hotel chain's competitors, which can draw away customers and force them to cancel their bookings. Another reason is because of changes in seasons. So certain travel periods might experience more adverse weather conditions, and so when customers' plans fall through, they will be forced to cancel their reservations. And moving on, I'll be diving deeper into each hypothesis. So for the first one, about lead time, we can look at the chart here. So cancellation rate seems to be much higher as the lead time increases. And so this backs up the hypothesis here. And if you look at the highlighted box there, so for bookings who have more than 480 days lead time, there's near 100% cancellation rates for most of the bookings there. So just looking at this, you might think that the hotel chain should actually focus on bookings that centers around bookings that have higher lead times, because they are experiencing such high cancellation rates. So maybe there's a lot that can be done to mitigate this. However, while it's important to consider cancellation rates, the business impact should also be considered as well. So if you look at the two charts here, we can see that the number of bookings as well as the number of cancellations seems to be centered and clustered around shorter lead times. So what this tells us is that if efforts were made to try to reduce cancellation rates among these shorter lead times, it can lead to much more significant business benefits. So while it's important to craft solutions that target bookings, so this tells us that it's more meaningful to craft solutions that target bookings with lower lead times, even though cancellation rates are lower, because the business impact can be maximized. So moving on to the deposit type hypothesis. So if you look at the charts here, the hypothesis does not seem to hold true, and very unintuitively, cancellation rates are significantly higher when deposits are non-refundable. So cancellation rates are not only higher, they are near 100%, which is like a statistical anomaly and requires further investigation. And so we have sought the help of ChatGPT for this to identify reasons for this discrepancy. And some of the reasons that are provided is like maybe unforeseen circumstances, change in plans, or maybe there's miscommunication during the booking process. So all these reasons, while valid, they generally refer to outlier scenarios that are harder to generalize to a particular group behavior or trend, which is why we decided to take a deeper look into the data set and realize that there's only 162 refundable bookings that were made within the data set. So it further supports that these are outlier conditions and more data needs to be provided by the customer, by the client, before we can make any conclusive decisions. And finally, the last hypothesis is about bookings falling on peak traveling periods having higher cancellation rates. So from the chart here, we can see that cancellation rates peak near the popular periods, which is around April to June. So the cancellation rates is the blue bars that you can see there. So during these periods, the total number of bookings are also higher. And this aligns with both the client's domain knowledge as well as LLM's findings. So when we try to prompt ChatGPT to give us possible reasons for why seasonal trends can affect cancellation rates, they also give us very similar conclusions. So now I'll pass the time over to Kane to talk about clustering.
So we also attempted to find out the customer segments of the hotel. So our objective here is to identify the different customer segments and what are their properties. So from a marketing standpoint, this is important because you can upsell the different products to the different marketing customer segments. So we attempted in elbow plot, and looking at the plot, you can see that the optimal number of customers is 3. And the two tables here shows the value of the centroids from the clustering. And from the centroids that we identified 3 main customer segments, which is your couples, families, and extended stay. Yeah, so for couples, you can see that the centroids identified almost 2 adults with no children, and their ADR is the daily rates of the hotel. Whereas families, you can see that there's involvement of children and also more special requests. And extended stay usually have longer stay period as well as a longer lead time. Yeah, so this is what we identified manually by ourselves. And we actually did the same prompt to ask ChatGPT to identify these market segments. And these are the results that were generated. So they identified 3 segments, which is business travelers, leisure travelers, and also extended stay periods. So we felt that it didn't really capture the proper market segment because there were no clear indications of a business traveler based on the centroids of our clustering. So we actually relabeled them as couples, for example, because we felt that it has no children and it properly captures the customer segments better. And for leisure travelers, we relabeled them as family because we identified children as an important factor there. Yeah, so this is the difference between what we identified and what ChatGPT identified in terms of the clustering. So in terms of rating the overall performance, one good thing is that ChatGPT managed to provide us a few good feature importance methods for us to weigh and evaluate our clusters. But the downside is that they actually identified the wrong clustering method. Okay, as mentioned previously, our data set contains both numerical and categorical data, which is quite significant on data set. And the proposed method they used was k-means clustering, which was only applicable to numerical data. So we had to prompt it to use other methods such as k-prototype in order to cluster it properly. So moving on to the models, the first model we used was random forest. I think the model performed pretty well with area under curve of 0.91 and identified several features under the feature importance table. But at this point of time, since we are still working on the project, we felt that some features don't really make business sense because no deposits and no refunds are equally being weighed as important. So we might need to fine-tune our model moving forward. And similarly, one positive thing about asking ChatGPT to tune our hyperparameters is that they gave us an extensive list of hyperparameters to tune, which was quite comprehensive. But the downside is that it was actually too wide, so it took a very long time for us to go and train and tune the random forest. So we had to manually adjust and tweak the parameters as well. And I think this is also a consistent problem mentioned by the previous group. So somehow ChatGPT always provides, always sets the default scoring as accuracy. Yeah. So, and we felt that like other matrices such as the area under curve would be more appropriate because accuracy is a bit too simple. Yeah. And one interesting thing to note is that bridge search cross validation seems to be the most probable response when asking ChatGPT to tune hyperparameters. I think a few other groups mentioned this same problem as well. And when we asked why is it that this is the default response, they said it's because it's easy to understand and quick and can be implemented easily. There's some problems that we faced along the way is that our model performance actually decreased after we tuned the hyperparameters. Yeah, so this is something that we need to relook into moving forward in our project. Yeah, and this is just a PSA that I noted, trying to debug this problem. When I realized that it's just a bug between MacBook and Windows. Yeah, so Windows actually you can see the confusion matrix. For MacBook, somehow it's not appearing. Yeah, so just take note.
Yeah, so moving on to the second model, which is neural network. So we actually use the help of ChatGPT to help us create a code to create this neural network. Even though we do not have much experience with this, it really came true. So actually the neural network model produced very good AUC results, and it indicated that children as the most important variable that will influence this, the target variable, which is the cancellation. So through this process, we actually try to include prompt engineering techniques to try to get the most effective results, and to try to make the whole process very efficient and try to optimize it as well. So for the first technique that we used was providing context to ChatGPT. So what we did was actually to type out the different columns and provide context in our own words as to what they represent, and also the column value. So for example, is what the column type? Is it a string value? Is it a numerical value? So this will help optimize the whole process afterwards when we ask it to generate code, because some code might work for integers but will not work for string values. So by providing this context, it can generate more accurate and relevant results. And for the second point, we use prompt completion, because generally when you ask ChatGPT a question, they'll provide their answers in prose. And so to make the whole, again, to make it optimize the whole process, we try to prime the LM to respond with Python codes, which can speed up the whole code generation process. And lastly, we use instruction prompting to try to reduce inference time and optimize the whole process. So providing a step-by-step instructions on what the steps ChatGPT should take to give us the ideal result that we had in mind. So all these techniques actually benefited our code generation process, but while prompt engineering improves the efficiency as a whole, there's still much to be done there's still much room for its improvement. So these are some of the issues that we faced while using LLM. So the first issue is that there were incorrect usage of pre-built functions used in the code generated by ChatGPT. So when we prompted ChatGPT to provide a code to create a neural network, they actually asked us to encode our data using this label encoder function. So this is a pre-built function that's only supposed to be used for target variables when we look at the documentation. And the reason for this is actually because it provides it orders the data in some sense, which we do not want for our X values. So to resolve this, we again asked ChatGPT to provide to encode it in a way that we intended. And however, it produced very inefficient code. And so this is issue number 2. So it produced static code that cannot be that is harder to fit into the rest of our code. It's harder to generalize and also harder to scale. And finally, for the last issue, it ignored specific instructions. So as Keynes mentioned and other groups mentioned as well, so even though we explicitly told ChatGPT to use ROC AOC as a way to evaluate our model, they still insisted on using accuracy. So this had to be manually adjusted on our end. And now maybe we'll talk about the last model.
Yeah, moving on to the last model, so we actually use the XGBoost. So you can see on the left for the ROC curve, in comparison to the other two models, it actually had lower AUC of 0.87. But if we see the feature importance, we can actually see that lead time was identified as the most important feature, which I think is good for us because we also tried to do some analysis on previously about the lead time. And moving on, we also can see some issues that we faced during the hyperparameter tuning. While on the left side, we can see that they actually provided sufficient parameters for me to tune, as well as listening to my instructions on how I want the scoring matrix to be, which is the AUC. But on the right, as Case mentioned, the grid search was taking a bit too long, so I had to ask them to provide an alternative parameter tuning method, and it also maintained like the scoring metric of the ROC, AUC.
So moving forward in the next few weeks of our project, we will start to clean up and combine our code and also retune our hyperparameters for our model, and also select the correct models. So as of now, we have 3 different models here, and the metric that we use is the ROC AUC curve. And looking at this, we can conclude that neural network has the highest AUC. And this supports, because our data set is very big also, so that helps with the neural network model. Yeah, but why we feel that AUC is like a good enough method to choose a model, we feel like there needs to be other considerations as well. So in terms of a business point of view, I think the cost of wrong errors is quite important. That's why we decided to bring in the type 1 and type 2 error. Yeah, so it's a bit counterintuitive because our positive in this case means it's like a cancellation, so it's like a negative intuition to me. Yeah, but the idea at the end of the day is that we were comparing and deciding between type 1 or type 2 error and which one should have a higher weightage. And we decided that type 2 would be like the consideration that we will use. Yeah, because type 1 occurs when we predict that they cancel, but they actually didn't cancel. Yeah, and from the business point of view, like to upsell these customers, maybe we can give them like a $10 meal voucher. So the cost of that of a type 1 error is maybe like a $10 voucher. But cost of type 2 error is you wrongly identify customers that are not going to cancel, and the cost of that is the entire booking, which is $100 a day, which is quite a large amount compared to the type 1 error. That's why we decided that we will use the area under curve and type 2 error to compare and decide which model to choose moving forward. And lastly, the last part is to link it back to our business problem and come up with business findings, how to interpret the model, reasons for cancelling, and how to further reduce these cancellations. Thank you.
Right, thank you, SAGA. Let's have 2 questions.
Thank you for your presentations. Can I ask what motivates you guys to use a neural network for this business model, considering on a relatively small base to train such a
I think one of the reasons was because we have been learning about neural networks, so we thought we want to try it out. And also another one because, as Case mentioned just now, that we have a lot of data, we have a lot of rows of data. So we thought that neural network can better accommodate, can account for all the different categories and records. It's more effective in handling large amounts of data in our case. Yeah. So which is why we chose to use neural network.
Yeah, and at the same time, I don't think it's like a lot of work on our part because we just need to prompt ChatGPT to give us like the model. I mean, while we try to ensure that the code is like relevant, but largely it's like ChatGPT giving us the code to use.
Can I ask, like, you previously mentioned that you felt that the label encoder used by ChatGPT is not very effective. Like, can you explain more about that and like what else do you do instead of, because like we actually use that in something like that to like so like any columns or variables that are like categorical variables, you want to change it to encode it. So if like that's not what you did, then yeah, what was the change that you did?
So for that label encoder function, it was a pre-built function in one of the package. Yeah. So its intended use is actually supposed to be for encoding the target variables. So in this case, this cancel column that we have. So I think the issue, this was actually in the documentation. So they mentioned that it's only supposed to be for target variables. So they didn't specify why, but when we went to try to look for the reason, one of the reasons was because it provides a sort of an order to the data set. So instead of encoding like maybe 0, 1, whatever, right? Because target variable is only 2 outcomes, 0 and 1. But if your other variables have a lot of different categories, it might have like 0, 0, 1, 2. So this gives it sort of an order to it, which is like information that might affect the data, the results at the end. And this is not from the data itself. It might introduce some bias to it.
So you all use another encoding method?
Yeah, we just use a simple like the one hot encoding. Because if we wanted to preserve like the ordinal nature, right, we just use the ordinal encoder, which which is meant for like the features. But when you read the documentation, like label encoder is just specifically for the target variables. So you don't want to like give inaccurate data to the neural network to train.